All right. Hi, everybody. Today I'm going to be walking you through how to build some logic gates in Minecraft. So this is a pretty fun thing to do. It teaches you a little bit about the basics of computer science, electrical engineering, and mathematics. We won't be going through all the different logic gates that you can make because there's plenty of those. Um, but I'll encourage you to do that on your own. After you've taken a look at this simple project. So what we will do though is use some of the logic gates that we build today to build a half adder. And that half adder will be used to add together some binary numbers. So just a little bit about the inspiration for this project first. So recently got done reading a text on video games and literacy, and how video games can help us not only become literate in other subjects and inspire us to do research into other subjects, but just how becoming literate in video games itself helps reinforce that exploration and discovery aspect of learning. Today, we're going to be using Minecraft as our example. So, Minecraft's really great because it's a creative game at its heart. You can load up like a creative world, like I did here, make it a super flat world, and you don't have to worry about actually like playing, the survival mode or anything like that. You can just build stuff, and it's relatively cheap. You can pick up a copy of Minecraft Java Edition for under $30, digital download via Minecraft's website. It runs on Windows, Mac, and Linux, and maybe FreeBSD. I'm not 100% sure on that though. And you can have a really great experience building some stuff. So, uh, really, the point here is that I want people to become maybe inspired to build something in Minecraft themselves that teaches other people, or teaches themselves throughout the project how to how computers work, how the a basic CPU might work. And you certainly can do that. You can build your own working computer in Minecraft using just the blocks that are available to you in the game, which is really really cool. How can you build logic gates in Minecraft, or just like how does like electricity work in Minecraft? So there's a couple different blocks that we have. We have this redstone dust, and this kind of works like wire. It carries a signal. You can kind of put back on itself and do all sorts of stuff with it. You can carry it over blocks, so need one wire to like cross over another wire or something. You can do that. We also have these redstone torches, which provide power. So you can see right now the redstone wire has a signal coming out of it. So we'll refer to anytime there's a charge going through the redstone dust through the wire. We'll refer to that as a signal. That right now there's signal here. Signal going through there because of the redstone torch. And we also have these levers which have an on and off position. So you can see if I point at it, it has like the little red dust coming out of it, meaning it's in the on position. If I connect up some redstone wire in really any direction, you can see I can flip the switch and turns on. We've got signal in 3 directions now. So pretty simple the way that it works. We don't have to be concerned with voltages, amps, or watts or anything like that. We just need to be concerned with the on-off state of the switch, and a signal going through the redstone wire or redstone dust, and the state of the torch, whether the redstone torch is on or off. I should mention too, you can actually turn the redstone torch off by, do this correctly here, flipping this switch. See, I flip the switch and it actually powers off the redstone torch. So that's kind of cool. That'll be helpful later. We'll also probably use some of these blocks here. These blocks will light up when you put some signal into it. They'll light up. So those will be helpful later on. Anyways, let's get going here. So most basic type of logic gate that we can make just takes one input. We'll call it input A, and it gives some output. And when the switch is off, we have no signal, no output. Turn it on, and we have a signal. So that's most basic input-output logic gate we can make. Now we could actually invert that signal, and we can make a NOT gate or an inverter. And the way the inverter works is we throw down a lever here, and we put a redstone torch here, and then we connect up some of our wire again. And you can see right now the lever is off, but we have signal. Now the lever is on, and we have no signal. So we've now effectively inverted our signal from our original basic input-output gate. All right, so another type of logic gate here. This one will actually take two inputs. It's going to take an input A and an input B, and you'll have some output. So those you'll do a logical OR between inputs A and B, and depending on the result, depends on what output you get. So or we can have A or B be on to get signal, or both. So A and B on, still have signal. We now just have B on, and we still have signal. But if they're off, then we have no signal. So there's three states in which we could have signal, and one state in which we don't have signal. So A and B both being off produces no signal, but in any situation where at least one of, I didn't mean to break the lever, at least one of the inputs is on, then we have signal. So I'll just leave this on for now. What else do we want to do here? So next, let's build an AND gate. So this is kind of building up to, again, like I said, we're not doing all of the logic gates today. We're just kind of building up to the ones that we need to make our half adder, our binary half adder. So we'll do an AND gate next, and then we'll be very close to being able to actually build our half adder. So we'll take the AND gate here, and how do I want to do this? We will put a block here. So again, this one's going to take two inputs, and it's going to do a logical AND between input A and input B. And we're going to connect up some wire here. And put down a block. Okay, so A and B are both off, so we have no signal. A is on, B is off, no signal. Likewise, if I turn B on but A off, no signal. Turn them both on though, and we have signal. So this is the states we could have here are A and B both on, give signal, but in all other cases, no signal. All right, so the last gate that we want to work with, and we set the time of day actually, so it's bright again, and we can actually see a little bit better what we're doing. So the last gate we want to make is called an exclusive OR gate, an XOR gate. So the way this gate will work is, again, it's going to take the two inputs, and then it's going to do an exclusive OR, logical exclusive OR, to determine what the output is. And the way this will work is, or the states that you can have are A can be on and B off. That will give signal. B can be on and A off, and that will give signal. But in all other instances, there's no signal. So it has to be exclusively A or B that is on for signal to come out. And this is a bit more of a complicated logic gate, but not too complicated. It does combine the AND gate with several NOT gates in order to create exclusive OR. So let's see we've got some NOT gates up here, and we'll throw a light here. That is powered right now because this isn't all connected up yet. Don't worry too much about that. So let's put on our input A and input B. Okay, so you can see right now A and B are both off, so no signal. We turn A on and there's signal. Likewise, we turn B on and A off and there's signal. But if we turn both on, no signal. So this is exclusive or not. It's not like the simple OR gate that we built back here, where if both were on, you would still get signal. All right, so I think we're ready to build our half adder. And actually, to do that, we don't need to remake all these gates. We can actually use what we already have here on the ground. And what I'd like to do is actually fix this so that it looks a little neater, and we have the wire up there so it looks like it's connected. And I'd actually like to put some blocks up here. So it's a little easier to see. All right, so we want to connect together our AND gate and our exclusive OR gate. So our AND gate and our XOR gate are going to get connected together. And that way we can put the input A and input B through both gates, and we can get some output. So what does a half adder do exactly? It's fairly simple. So we're going to use binary. We're going to be working with binary numbers here. So we only have 0 and 1. We don't have 0 through 9 like we would in decimal. We just have 0 and 1 in binary base 2. So if I were to add together two numbers in binary, for instance, if I was to add together 0 and 1, then the result would just be 1. Same thing if I was to add together 1 and 0, the result is just 1. But if I was to add together 1 and 1, then the result is 2. However, we don't have 2 in binary. We only have 0 and 1. So what happens there? Well, it's the same thing as in decimal, where if you add it together, 9 and 1, you get 10. So you actually end up having to carry a 1 to the next column, right? If you're thinking about adding, column-wise addition. Same thing's happening in binary. We add together 1 and 1, we get 0, and we carry the 1. So carry the 1 to the next column, and then we add some zeros as placeholders or whatever you want to do, and then finish our addition there. So we get our result of adding 1 and 1 is actually 1, 0, which is binary representation of 2. The way our gates will work here is that this is just a half adder, not a full adder, so it doesn't actually display that result, but it does display a sum and a carry. So our carry is going to come out of the AND gate, and our sum will come out of the exclusive OR gate. So we will plop down. Oops, that's not what I wanted to do. Plop down some these with some levers. So our inputs A and B, they'll get flip-flopped when we connect them, but that doesn't matter. I'm also gonna set the weather to clear again. Deal with that sound. And let's go ahead and connect these up. So here, we'll make this one input A for the AND gate, and we'll make this input B for the AND gate, and then we'll make this one input A over here, just so we don't have to deal with like having one wire overlapping the other, and that will get kind of complicated. We don't want to do that. We don't want to make it complicated. All right, so this one will be input B, and usually what happens is I do have to like reset these to get them going. I think that worked. Okay, so everything should be set up. So right now we're adding together 0 and 0, because A is this input here is 0 and this input here is 0. So we have 0 plus 0 is just 0. So our sum over here is not lit up. That means that that's 0, and there's no carry, obviously, so that's 0 as well. So what's going to happen if we try to add 1 and 0? Well, result is going to be 1, and there's no carry. So our sum is 1, and our carry is 0. Likewise, if I add together 0 and 1, the opposite direction there, again, the result is going to be 1 for our sum, 0 for our carry. But if I was to add together 1 and 1, you can see what I was talking about before. We have 1 plus 1 in binary. Well, the result for the sum is 0 and the carry is 1. Now, if we were to build a full adder, we could actually display that result in a more meaningful way and say we have 1 0, which is binary 2. I mean, I suppose that is kind of what's being displayed here if you think about this carry as just being in that next slot over to the left of the 0. Then we have 1 0, and that is 2. But we're not going to build the full adder today because that's a more complicated logic gate. So my challenge to you is see if you could build a full adder by combining together the circuits that we've made so far. Could you take a half adder, connect in another half adder, and add in another AND gate and create a full adder? You can look up schematics for these types of logic gates freely online, and reproduce those here in Minecraft. So you can actually just use a traditional schematic to make that. You don't need to look up like a specific Minecraft schematic because, like I said before, these things work pretty much the same as they would with real circuitry. My second challenge to you would be, could you build something interesting using any of the logic gates that we did here, such as maybe an automatic door opener or make a piston move in a meaningful way? There's lots of these different blocks in Minecraft that do these types of things, but connecting them up to logic gates allows you to do even more interesting things. So I encourage you to take a look at what you could do, what you could create and design using these logic gates in Minecraft, and maybe take a start with the full adder. And at some point, you might even be able to combine together several full adders to make yourself a little bit of, like an adding machine, where you can add together bigger and bigger binary numbers. All right. So, having said that, I'll end the video here. I hope you found this interesting, and I hope you found, something that sparks your interest, in terms of computer science, math, electrical engineering, in this game. So, thanks.